Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR June 2024, Paper 2, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1, work out 6.3 plus 4.7. I think I might do this as a column addition, so I'm just going to rewrite it with the decimal point aligned, and then I'm going to add it up. So 3 and 7 make 0, carry 1, and then 1, 6 and 4 make 11. So that is 11.0, or just 11. And then for B, £4.50 minus 27 pence, I'm going to do the same thing. I'm going to do a column subtraction. So I'm going to write my two numbers, one under the other with the decimal point aligned, and then I'm going to do my subtraction. 0 take away 7. Well, I can't do that, can I? So I'm going to borrow 1 from the 5, make that 4, and make my 0 into a 10. 10 subtract 7 is 3. 4 subtract 2 is 2. 4 subtract 0 is 4. So that is £4.23. More arithmetic for question 2. I've got positive and negative numbers here though. Minus 7 take away 4. Now if I draw the number line, I'm not going to draw all of it, but if I put minus 7 there, then 0 is at this end. But if I'm taking 4 away, I'm getting more negative. So I'm going to go like 4 jumps to the left here, aren't I? 1, 2, 3, 4. Where does that take me? It's going to take me from minus 7, minus 8, minus 9, minus 10, minus 11. So my answer is minus 11. And negative 42 divided by 6. Well, 42 divided by 6 is 7, but a negative divided by a positive is a negative. And then finally, negative 4 squared. Well, that is negative 4 times itself. In other words, negative 4 times negative 4. And a negative times negative is a positive. So I'm going to get positive 16 for that one. Question 3a. Reflect the triangle in the mirror line. Okay, well, when I do these, I just count how far each point is away from the mirror line, and then I do its image point the same distance on the other side. So I'm going to take each of the 3 corners in turn. Let's start with the bottom one first. Now you can see that that's 1 unit away from the mirror line. So its image is going to be 1 unit away on the other side. Okay, and then the second one, let's take the middle one next. That is 1, 2, 3 units away from the mirror line. And its image is 1, 2, 3 units away on the other side. Then it's going to be here. Okay, one more to do. And then finally the one at the top, that is 1, 2 units away from the mirror line. And its image is 1, 2 on the opposite side then. So it's going to be here. Now, once I've got all my corners worked out, then the next thing to do is to join up my image like so. Question B, rotate triangle 90 degrees clockwise around point P. Okay, so when you see a rotation, put your hand up, ask the invigilator for a sheet of tracing paper if you haven't got one already. Put it on top of your grid. Mark the corners of your shape clearly on the tracing paper. You can join the points up as well if you like, but you know, it's the corners actually the most important thing. Next, I'd like you to draw a little cross through the grid lines at P, and then put your pencil tip in the middle of the cross, and then we're going to turn it anti-clockwise. Okay, so every time the cross lines up again, you've gone 90 degrees, so that's once. So 1/4 turn is fine, we're going to stop there. And then what you want to do is you want to carefully lift your tracing paper up at the corners and just kind of plonk the points down underneath your traced shape. And once you've done that, just remove the tracing paper and you can just join the points up then with a ruler, and then that's job done. Question 4. The radius of a circle is 3 centimeters. Find the length of the diameter of the circle. Well, when you've got a circle and we know that the distance from the center to the edge of your circle is 3 centimeters, then how far is it from one side of the circle through the center to the other side? Well, a diameter is made up of 2 radiuses if you think about it, so that's just going to be twice as much. It's going to be 6. So 6 centimeters. Question 5. This probability scale shows the probability of picking a blue counter from a bag of counters. So I guess the probability then is this little number down here, the one it's pointing to. Write down as a fraction the probability of picking a blue counter. Well, okay, so this probability scale goes from 0 to 1, and I'm one little division up from 0 to my marked probability. Okay, so how many little divisions are there altogether? There are 1, 2, 3, 4, 5, 6, 7, 8. So that means it's 1 division out of 8 divisions, so it's going to be 1/8. Okay. On the probability scale above, mark with an arrow the probability of not picking a blue counter. Okay, so the probability of not picking a blue counter. So if the probability of picking a blue counter is 1 out of 8, then the probability of not picking a blue counter is 1 minus 1/8. It's going to be 7/8. So where's 7/8 on the diagram? Well, it's going to be 7 jumps up, isn't it? 1, 2, 3, 4, 5, 6, 7, or 1 down from the other side. So I'm going to draw my arrow here at 7/8 then. Get rid of that. Okay, so 7/8. Question 6. A bathroom shower uses water at a rate of 15 litres per minute. How much water is used in a bathroom shower that lasts 12 minutes? Okay, well, if we're using 15 litres every minute and we're doing it for 12 minutes, then it's just a matter of multiplying those two numbers together, isn't it? So 15 times 12. What's 15 times 12? 5 2s are 10, so I'm going to let 0 carry 1. 1 times 2 is 2, plus 1 is 3. I've run out of digits to multiply on my 2 by, so I'm going to add a 0 and start multiplying the 1. 5 times 1 is 5, and 1 times 1 is 1. So adding those up then, 0 and 0 make 0. 3 and 5 make 8, and 1 makes 1. So that's 180 litres of water. And that's why you shouldn't spend 12 minutes in the shower. Cut it down a bit, save some water. 7a, write 0.6 as a fraction in its simplest form. Well, this digit here is tenths, isn't it? So 0.6 is just literally 6/10. So 6 over 10, but 6 and 10 share a common factor. They're both even numbers, so I can divide them both by 2, can't I? So 6 divided by 2 is 3, 10 divided by 2 is 5. So that makes my final answer 3/5. B says, write 17 over 5 as a mixed number. Okay, well, I've got 17/5. The way we do this is we work out how many 5s go into 17. 5s into 17 go 3 times. And the remainder, which is 2, because 5 3s are 15, so we've got 2 extra, is the numerator of the mixed number. And then the denominator is going to be 5. So it's 3 2/5. Question 8. Use one of these symbols, less than, greater than, or equals, to make each statement true. Now, is 60 millimeters less than, greater than, or equal to 6 centimeters? Well, there are 10 millimeters in a centimeter, so they're going to be equal to each other, aren't they? 320 grams and 3.2 kilograms. Well, 3.2 kilograms, that's 3,200 grams, isn't it? So that is definitely a lot more than 320 grams. So I'm going to put that less than symbol in there. 1 3/4 of a kilometre versus 17,500 metres. Well, 17,500 metres is 17.5 kilometres. That's a lot more than 1 3/4 kilometres. So I'm not going to bother redoing the fraction. I can see straight away it's going to have to be that way round. Question 9. Work out the following, giving each answer as a fraction in its simplest form. Okay, so 17 over 16 minus 1/4. Now, when do you want to do fraction subtraction? These numbers on the bottom need to be the same, and they're not. So what I'm going to do is I'm going to find an equivalent fraction for 1/4 by multiplying top and bottom through by 4. Now, the reason I'm multiplying through by 4 is because 4 4s are 16, and so I've then got a matching denominator for both fractions, look, 16 and 16. So now the denominator is the same, I can go ahead and subtract the numerators. 7 take away 4, that's going to be 3 then, isn't it? So 7 take away 4 is 3. So my answer is 3 over 16. For B, I've got fraction division. So when you've got fraction division, we use keep, change, flip, don't we? Kind of that. It's almost like a very popular fast food place. So we're going to keep the first fraction the same, 5 over 12. Change the divide into a times and flip the second fraction over. So I'm going to end up with 9/5. Okay. Now you could go ahead and times top with top, bottom with bottom, but then you would have to then go and factorize. It's actually quicker to do your cancelling before you factorize. So, I mean, yeah, I mean, if you find this confusing, just go ahead and multiply through and then cancel down. But personally, I look for common factors top and bottom before I multiply. So I can see I've got a 5 there and a 5 there, so they cancel down, give me 1 and 1. And I've got a 9 and a 3 here, and they cancel down because they both divide by 3, giving me 3 and 4. Okay, so once I've done that, that makes the multiplying a whole lot easier. 1 times 3 is 3, 4 times 1 is 4, it's going to be 3/4. Okay, so you can multiply and then cancel, but it's actually a lot easier to cancel and then multiply once you get the hang of it, because you end up with dealing with smaller numbers, and it's actually easier to spot the factors when you've got more numbers like that, I think. A little bit of algebra. I'm going to collect some light terms here. I've got terms in y. I've got 3y and minus y. And I've got terms in x. I've got plus 6x and plus 5x. Now notice when I was highlighting them, I was highlighting the term and the symbol in front of them, because that sign belongs to the term that follows. It doesn't really have anything to do with the thing in front of it. So this reads 3y take away y. So I've got 3y and a take away y. That's 2y then, isn't it? So y is taken away the y's is 2y. And then adding the x's together, I've got 6x and 5x. 6x plus 5x is 11x. So that's plus 11x. Okay, so 2y plus 11x is my final answer for that one. And then I've got 5a times 6b. Now, when I'm multiplying terms together, I kind of multiply like with like. So I've got 5 and 6, which I'm going to multiply together. That's going to give me 30. And then I've got a single term in a. Okay, so I'm just going to have to write a by itself because I've only got one term. And I've got a single term in b. So I'm going to have to just write b by itself because I've only got that single term. Okay, so then I get 30ab as my final answer. 30ab. Question 11. The table shows the plan view and front elevation of some 3D solids. Write the name of each 3D solid in the third column of the table. Okay. So if this thing has got a plan view of a rectangle and a front view of a rectangle, then I think what we've got here then is a cuboid, isn't it? So that first one is a cuboid. Should be fairly straightforward. The second one, the plan view is a circle and the front view is a triangle. So I think here what we've got is a cone, isn't it? That's a cone, that one. So I drew my cone slightly off the page there. And then finally, I've got a plan view, which is a rectangle with a line in it. So rectangular base. And I've got a triangular front face. So I'm guessing what I've got here is like some sort of triangular prism. Yeah, I think it's a triangular prism. Okay. So like the tip of the triangle is that line that you see there, isn't it? Okay. Question 12. A says 6 to the power 3 times 6 to the power 4 is what? So if I'm multiplying numbers with the same base, I add the indices together. So that's going to be 6 to the power of 3 plus 4. And that's 6 to the power of 7. And then I've got 2 squared all raised to the power 4. So when I've got an index of an index like this, an index raised to another index, we multiply those together. So 2 times 4 is 8. So that one is 2 to the power of 8. That's your laws of indices. Question 13. Work out the next term in this sequence. I've got 1, 3, 6, and 10. Okay, now there are 7 different types of sequence that you need to know for your exam. I'll put up a little list here. Then the first 3 are just kind of, they're really just kind of like properties of numbers. So, you know, you've got your square numbers, you've got your cube numbers, you've got your triangle numbers. Now, I recognize this sequence as the set of triangle numbers, isn't it? It's 1, 3, 6, 10. Now, the reason this is the triangle numbers because you can take that number of things and arrange it into a triangle. Okay. If you ever played 10-pin bowling, you know that 10 things make a triangle. So yeah, there we go. So what is the next term in the sequence? Well, the next one would be another row added onto the bottom of this one, wouldn't it? So 5 extra ones on the bottom. And again, if you ever played pool, you'll recognize that. It's the number of balls in the triangle when you set up the table. Right, and then the part B says in the Fibonacci sequence below, the next term is found by adding the 2 previous terms together. The second term is 7, the third term is 10, and the fourth term is 17. Work out the first and the fifth terms of the sequence. Okay, well, Fibonacci type sequences, you get the next term by adding the 2 previous together. So the last one is fairly straightforward. Just have to add those 2 together. It's going to give me this number here then. So 10 plus 17, that's 27. Now, what about going back the other way? So going back the other way, I'm going to have to kind of do the opposite then, aren't I? So something plus 7 is 10. So what plus 7 is 10? It's going to have to be 3, isn't it? So kind of working backwards. 3 plus 7 is 10, so that one must be 3. Question 14. Use the formula v squared equals u squared plus 2as to find the final velocity when the initial velocity is 6 meters per second, the acceleration is 4 meters per second, and the distance traveled is 8 meters. Okay. So this is one of the kinematics formula, or I call them the SUVAT formulas because they're the letters that are involved in all of these formulas. SUVAT, where S is the distance, U is the initial velocity, V is final velocity, A is acceleration, T is time. Okay, so when you've got a question like this, these are the 5 values that get involved, and normally you've got 3 or 4 of these, and you can use the formulas to find the others. Okay, so what have we been given in this particular problem? We've got the initial velocity is 6 meters per second. Now that's U, so that is 6. And then what else have we got? Acceleration is 4 meters per second. That's A. 4 meters per second. And then we've got distance, which is 8. So that's actually S for distance. Okay, so 8 meters. Don't know why it isn't really called DUVAT, but anyway, it isn't. It's called SUVAT. Right, so yeah, they're the ones we've got. And what do we want? We want V, I guess. We want V. So we don't really need T for this one. We want V. And that's handily at the front of my formula already, so I don't need to rearrange it in any way. I just need to plug the numbers in then. So v squared equals u squared. That's going to be 6 squared plus 2a, which is 4, times s, which is 8. Okay, so what's that then? 6 squared is 36. 2 times 4 times 8. Well, 2 times 4 is 8, times 8 is 64. So then adding them together, 36 and 64, well, that's 100, isn't it? So I know that v squared is 100. So what's v then? V is going to be the square root of that, and the square root of 100 is just 10. So my answer is 10 meters per second. That's the final velocity. Question 15. Compost is used to grow plants. Ivan has a sack containing 50 litres of compost. He uses this compost to fill pots for his plants. Ivan fills 6 large pots, each holding 7.5 litres. Work out how much compost is left in the sack. Okay, so he's got 50 litres of compost, and he's filling 6 plant pots, which each hold 7.5 litres. So what we need to know is work out how much is 6 lots of 7.5 then, isn't it? That's what we need to know. 5 6s are 30, that's 0 carry 3. 7 6s are 42, plus the 3 is 45. So that is 450. There's 1 digit behind the decimal place there, so there's going to be 1 here as well. So that's going to be 45. So if he's got 45 litres used, then remaining is going to be the 50 litres he started with minus the 45 we just worked out. So 50 minus 45, what's that then? So I just made a mess of my 5 there. 50 minus 45, that's 5 remaining then. Now, Ivan uses the remaining compost to fill small pots, each holding 400 millilitres. Work out the maximum number of small pots Ivan can fill with the remaining compost. Okay, so what we want to do here, we've got 5 litres. 5 litres is the same thing as how many millilitres? So there are 1,000 millilitres in a litre. So 5 litres is 5,000 millilitres. Okay, so then we've got the same units as the pots then. The pots are in millilitres. So the number of pots that I can fill is going to be the amount of compost that I have divided by the amount of compost in each pot. Okay, now lots of zeros here, so let's cancel some off. I've got 2 on the bottom, they're going to cancel with 2 on the top. So basically I'm left with 50 divided by 4. So divided by 4 is half in and half in again. Half of 50 is 25, half of 25 is 12.5. So that means he's got enough compost for 12.5 pots. But obviously, you can't have a pot with half filled, because that's no good for anybody. So that means you can only really fill 12 pots. And then finally it says work out how much compost will be left in the sack. Well, if he's got 12 pots and each pot holds 400, then 12 lots of 400 is what? 12 times 400. 12 times 4 is 48 and 2 zeros. That's 4,800 millilitres of compost used for the little pots. Now you remember we started with 5,000, so 5,000 minus 4,800. That's going to leave us 200 then, isn't it? Question 16. The table shows how much Amaya earns per hour. Work done on Monday to Friday is £20.15 an hour. Work done on Saturday or Sunday is £30.23 an hour. 1 week, Amaya works for 40 1/3 hours between Monday and Friday, and then for 4 1/4 hours on Saturday. Amaya says, I will earn at least £900 for my work this week. By rounding each value to the nearest integer, used estimation to show that Amaya may be correct. Okay, so I need to round everything off. So £20.15 to the nearest integer is going to be £20 to the nearest pound then, isn't it? So that's going to be £20. £30.23 to the nearest whole number is going to be £30. 40 1/3 to the nearest integer is going to be 40, and 4 1/4 to the nearest integer is going to be 4. Okay, so now I've rounded everything off. I can then try and work out how much, well, an estimate of how much she's going to earn then. So from Monday to Friday, she earns, well, it's going to be £20 an hour times the 40 hours that she works. So 2 times 4, that's 8, isn't it? And then I've got 2 extra zeros on the end of that, so 0, 0. So I'm going to add my 2 extra zeros on the end. So that's £800 then she earns from Monday to Friday. And then Saturday Sun, she earns, well, she's earning £30 an hour this time, and she's working 4 hours. So 30 times 4, again, 3 times 4, that's 12, plus 1 extra 0. That's going to be 120. So total is going to be those two amounts added together. So 800 plus 120, that's 920 then, isn't it? Okay, so yeah, we've shown then that she can earn more than 900. That's more than 900. Part B says, give one reason why your working in Part A shows that Amaya can be certain of earning at least £900 for her work this week. Now, I think that comes down to the fact we rounded everything down. So if you remember, the money was £20 and some pence and £30 and some pence, and it was 40 1/4 hours and 4 1/4 hours, and every single one of those numbers got rounded down. So the actual number is going to be bigger for each of those numbers, isn't it? So each one of those is slightly bigger, so each one of those is going to make the total slightly more. So yes, I'm going to say that every number we used in the estimation was rounded down, so the true amount has to be higher. Does that make sense? Every number we used in the estimation was rounded down, so the true amount has to be higher, is what I wrote. Work out 1.2 divided by 0.03. Now, when I've got division of decimals like this, I find it easier just to get rid of all the decimals straight away. So if I've got 1.2, I'm just going to write it as a quotient like this, like a bit of a fraction. And then you notice the number on the bottom is 3/100. So if I times that by 100 and that by 100, I'll come up with an equivalent fraction then, won't I? So 1.2 times 100 is 120, and 3/100 times 100 is 3. So that's the same thing then as 120 over 3, which is a lot easier to do. That's 40 then, isn't it? So 40. Kai has these 4 number cards. We've got 0, 2, 5, and 9. Kai takes 2 of the numbers at random without replacement and finds the positive difference between the 2 numbers. Complete the table to show all of the possible differences. Okay, so just first thing to note here is it is without replacement. That's why we've got these shaded boxes down the middle, because if you pick the 0 card on the first selection, then it's not available for your second one, is it? You've only got the other 3 cards to pick from. Okay, so that's why the middle kind of diagonal there is shaded in, because you can't get 0, 0 or 2, 2 or 5, 5 or 9, 9. Okay, what you can get is 0, 2, 5 or 9, or 2, 0, 5 or 9, and so on. Okay, so what we do, we're adding the cards, are we? The difference between the 2 cards. We'll take one away from the other. Okay, so this box here then is 9 take away 2, which is 7. Then I've got 5 take away 2, which is 3. So it doesn't matter if it's positive or negative. It's not taking the second card away from the first. It's just the smallest one away from the biggest. So 9 take away 5 is 4. And then we've got 9 take away 2, which is 7. And 9 take away 5, which is 4. Okay, so that gives us that table of results then. Now part B says find the probability that Kai takes 2 cards with a difference that is an even number or a factor of 10. Right, so what are the even numbers? Even numbers are 2, 2, 4, and 4. They're the even numbers. What are the factors of 10? Factors of 10. What's that? We've got 1 and 10, 2 and 5. So we've already done the even numbers, so we just need to look at 1 and 5, see if we can find any of those. Well, I've got a 5 here and here, haven't I? They're both factors of 10. 9, 3 and 7 are not factors of 10, nor are they even. Okay, so I think we've got them all. So what is the probability that Kai takes 2 cards with a difference that is an even number or a factor of 10? Well, there are 1, 2, 3, 4, 5, 6 being either or, isn't it? So that's the number on the top, 6. And how many numbers are all together? Well, normally I do 4 times 4, it should be 16, but remember we've got that diagonal down the middle that doesn't have any values. So it's actually 16 take away 4, or 12 values altogether, isn't it? So there are actually only 12, which is the same thing as a half, but I'm not going to bother cancelling it down because I never do with these, because you never get any marks. I'm just going to leave it as 6 over 12. Question 19, using ruler and compasses only, construct the perpendicular bisector of the line AB. Leave your construction lines visible. Okay, so we need to do this with a pair of compasses. So get your compass out and make sure you've stretched it beyond halfway of the line AB. It has to be a bit longer than halfway. Between like 2/3 and 3/4 of the length of the line is normally a good amount. First, let's put the tip of the compass at A and draw the arc. And then moving the compass over to B and doing the same thing. We're going to draw an arc crossing the 2 lines like so. Okay, then once we've done that, we can just get a ruler out and then draw a straight line that runs through those 2 crosses then. So aligning the ruler first and then drawing a line through the points. Okay, so your line should end up looking something like that. Now, there's no harm in getting a protractor out if you've got a bit of time in the exam to just check that is 90 degrees and also measure the distance from A to B and check that your line goes exactly through the middle. Okay, but it needs to be constructed with compasses and you need to have these arcs visible, otherwise you're not going to get any marks for this question. No arcs, no marks. Question 20, vector A is drawn on the grid. Part A says, write vector A as a column vector. Now, when we draw column vectors, they're in the form x, y, where x is the distance between the start and end of your vector in the direction of x. So if I start on the top of A and I go 2 to the right, that means I'm going to have a 2 in my vector like that. And then it's 2 down. Now up is positive, down is negative, so that is going to be 2 minus 3 for that one. So vector A is 2 along and minus 3 up, which is 2 minus 3. Part B says a vector is drawn on the grid. Write this vector in terms of A. Well, you notice it's exactly the same line as the first one. It's just the arrow is pointing in the opposite direction. So this one must be minus A, because if you've got a minus vector, you're going in the opposite direction to the positive version of the vector. So that one must be minus A. Part A. Ryan makes a journey of 200 miles from his home to the coast. 1/10 of the journey is on roads with a speed limit of 40 miles per hour. 40% of the journey is on roads with speed limits of 50 miles per hour. The remainder of the journey takes a time of 1 hour and 30 minutes. Ryan leaves home at 8:50 and does not exceed the speed limit of the journey. Find the earliest time that Ryan could arrive at the coast. You must show your work in. Okay. So we've got 3 stages of this journey, haven't we? So I'm going to divide up my working into those 3 stages, and then hopefully we can combine them together. So what we've got in stage 1. Stage 1 is the bit up here where he makes 1/10 of the journey of the roads with a speed limit of 40 miles per hour. Okay, so these are going to be like distance, speed, time problems, aren't they? So I'm going to just draw them my little DST triangle here. What's distance, what's speed, what's time for stage 1 of the journey? Well, there's 200 miles altogether, look, and 1/10 of the journey is on road. So 1/10 of 200, that's going to be a distance of 20 then, isn't it? So that's 20 miles. Speed limit of 40 miles an hour. We're going to assume then that he's going to do the whole of that journey at 40 miles an hour. I know you actually have to kind of speed up to 40 miles an hour, but we're going to assume he kind of instantly accelerates and goes at 40, I think. So speed is going to be at 40 miles per hour. So what we want to do then is work out time. That's a thing we don't have, isn't it? So what is time? Time, let's cross out time. Time is distance over speed. So let's just write that down. Time is distance over speed. So that's 20 over 40, that's 0.5. Now that's going to be in hours, isn't it? So that's going to be half an hour. Okay, so for stage 1 is half an hour. Now moving on to stage 2 of the journey. Stage 2 is this bit. 40% of the journey is on a road with speed limits of 50 miles an hour. Okay, so again, DST, what's distance, what's time, what's speed in this part. 40% of the journey, what's 40% of 200? Well, that's 0.4 lots of 200, isn't it? Or 10% is 20 miles, so 4 lots of 20 is going to be 80 miles, isn't it? Another way of doing it. So anyway, the distance is 80 miles. And for that 80-mile stretch, the speed limit is 50 miles an hour. So how much time are we spending on stage 2? So again, time is distance over speed, which is 80 over 50. So that's 8 divided by 5, then, isn't it? What's that? That's goes in once remainder 3. So it's 1 3/5 or 1.6. I'm going to say 1.6 hours for now. So 1.6 hours for stage 2. And then the remainder of the journey, so the final kind of stage, is 1.5 hours. So it doesn't really say what to do there. That's quite easy then. So stage 3, nothing to calculate. We just know that time taken is 1 hour 30 minutes, which is 1.5 as a decimal, isn't it, of hours. Okay, so then what do we have to do now? Ryan leaves home at 8:50 and does not exceed the speed limit. Find the earliest time. Okay, so if we're at 8:50 and we need to add on half an hour is 30 minutes. And 1.6 or 1 and what we say, there's 1 3/5, wasn't it? So what's 3/5 of an hour? So it's going to be 1 hour and 3/5 of an hour. So 3/5 of 60 minutes. Well, 5 goes into 60. 3/5 of 60. What's that? So 5 goes into 60 12 times, isn't it? And then 3 lots of 12, that's 36. So that's 1 hour 36. And then the last part of the journey, remember, was 1 hour and 30. So we're going to add another hour and 30 minutes on top of that. Okay, so what's that all together? So that's our starting time. Then that's our stage 1 time. That's our stage 2 time. That's our stage 3 time. What's that add up to? So I've got 50 minutes, 30 minutes, 36 minutes, and 30 minutes. So that's 60, 110, 146 minutes. That's 2 hours and 26 minutes, isn't it? So it's going to be 26 carry 2. I'm going to carry 2 extra hours into the next column. So then I've got 8, 9, 10, 11, 12. So that's 12:26 then is the earliest he's going to arrive if he's going super fast and instantaneously accelerates. So that's 12:26. Now, I don't really need to put AM, PM on it. This one up here, look, is in 24-hour clock format, so I'm just going to leave it in 24-hour clock format. So it's 12:26. Now, part B says write down an assumption you've made when working out the answer to part A. Well, I've kind of mentioned it already, haven't I? The fact that we are instantaneously accelerating So we're going from 0 to the maximum speed, and we're going for the whole journey at that maximum speed. So Ryan is instantly accelerating to the maximum speed for each stage. Okay, so yeah, we're just assuming it, you know, he's from rest, suddenly he's going 40 miles an hour, which is not possible. But just to make the maths easier, that's what we've done. The scatter diagram shows the test scores for 20 pupils in science and maths. So we've got science along the bottom and maths up the side there. Part A says, describe the type of correlation shown in the scatter diagram. I think this is positive correlation, isn't it? You can see that generally reading this graph from left to right, the points are mostly going up in a band, aren't they? So that is positive correlation. It's probably what you would think as well, isn't it? You know, people who are good at science tend to be good at maths as well, and vice versa. Part B says, one pupil took the science test but was then ill during the maths test and had to leave early. On the scatter diagram, circle the point that is most likely to represent this pupil. Okay, so if he took the science test and did his normal standard in the science test, but was ill and had to leave the maths test early, we would look for a point then that's an outlier. Now there are two possible outliers, aren't there? There's the one up here and there's the one down here. These are the two outliers. Now this person at the bottom, they did well at science but poorly at maths, whereas the one at the top did well in maths but not so well in science. Now in this scenario, we would expect the student to do better in science because he's there for the whole of the science test. But if he's feeling ropey for the maths test and left before the end, then he's going to underperform probably there, isn't he, in the maths one? So I'm suspecting it's the one at the bottom and not the one at the top. So he did okay in science, but he did pretty poorly in maths. Then C says, by drawing a line of best fit, estimate the test score in mathematics for a pupil who had scored 28 in the science test. Okay, so first we need to draw a line of best fit. Now a line of best fit is a straight line passing through like the general course of the data. So I'm going to draw mine here, look. Now it's not an exact science. Yours might be slightly higher or lower or slightly shallower or steeper than mine, but it should generally kind of pass through the center of the data. It's a good idea to think about the number of points on either side of the line. They're vaguely balanced and it generally follows the trend of the line. I think that's all right. I'm quite happy with that one. Right, and so then now I've drawn my line of best fit. Estimate the test score in mathematics for a pupil who scored 28 in the science test. So what we're going to do is going to find 28 on science. That's down here, look, because there are 10 divisions between 20 and 30. So 28 is going to be 8 divisions up or 2 down from 30 then, isn't it? Right, so that's my 28. So what I'm going to do now is going to read up from that point till I hit the line and then turn left and read across. Okay, so hitting the line, going to turn around then and go the other way. Okay, so I'm reading that comes out to be pretty much 28 as well again, doesn't it? So 28, 28. Okay, so 28 in, 28 out. Seems reasonable. Explain why using the scatter diagram to estimate the test scores for mathematics for a pupil who scored 60 in science may be unreliable. Okay, well that's because all of our data, the main body of the data is here, look. So if we're looking up at 60, it's kind of outside the range of the data, isn't it? Okay, so you can see it kind of misses that central part of the data. Now when you're looking up within the data set, like we did with 28, that's called interpolation. What we're doing here is extrapolation, because we're assuming that the line is going in the same direction. It carries on kind of being linear up past the end of our data, but we've got no evidence for that. I mean, it could actually do that, or it could do that, we don't know. Okay, so we're assuming it goes straight, and therefore we're extrapolating. We don't know, it's not from a solid place, so that's why it's less reliable. So we're extrapolating, that's the proper word for it. So extrapolation, 60 is beyond the range of data in the scatter graph. Part E, find the percentage of the 20 pupils who scored less than 30 marks in both science and mathematics. So who scored below 30 in both? Well, look, here's 30 and 30. So it's the ones in this area here that we need to include then. And how many are there then? Now, this one up here, look, don't know about him. He's actually got 30. So is 30 below 30? I would say no, 30 is not below 30. So I'm not going to include him. So we've got 1, 2, 3, 4, 5, 6, 7 of them who are actually below 30 in both directions. Okay, so I make that 7 out of 20 then as a fraction. So what is that as a percentage? That is, well, if I want to make the number on the bottom 100, I have to times through by 5, don't I? So that's going to be 35 out of 100, which is 35%. The diagram shows an equilateral triangle and a rectangle. The equilateral triangle has the same perimeter as the rectangle. Find the value of A. Okay. Well, the perimeter of the triangle is pretty straightforward, isn't it? So the perimeter of the triangle is just the 3 sides added together, or because it's an equilateral triangle, it's just 3 lots of the one side, really, isn't it? It's going to be 3 times 14. So what's that? 14, 28, 38, 42. So that's 42 centimeters. So then, what's the perimeter of the rectangle going to be? The perimeter of the rectangle, well, it's going to be, if you walk around this, it's going to be A plus 5 plus A plus A plus 5 plus A then, isn't it? Okay? So it's going to be A plus 5 plus A plus A plus 5 plus A, which is equal to, I've got 1, 2, 3, 4 A's, and I've got 5 and 5. Well, 4 A's is just 4A, and 5 and 5 gives me 10, collecting like terms, isn't it? Okay, so I've got 4A plus 10 is the algebraic version of my perimeter, but because I know that these two things must be equal, I know then that that must be equal to 42. Okay, so if I've got 4A plus 10 is equal to 42, then 4A is going to be equal to 32, taking 10 away from both sides, and then dividing through by 4. 4's into 32 go 8 times, so I'm going to get A is equal to 8. Question 4. Charlie invests £1,200 at a rate of 5% per year compound interest. Show that the total amount of interest Charlie will have received after 2 years is £123. Okay, well, let's find out then. So 1,200 at a rate of 5% in compound interest per year. We're going to have to do it in 2 parts. So we start with 1,200. So if 100% from the start is 1,200, then what's 5%? Well, 10% would be that with a 0 taken away, divided by 10. And 5% would be half of that, would be 60. So after the first year, I would get my original amount plus my 5% interest. So at the end of year 1, I would have £1,260, adding that 60 onto the original amount. Okay, then I need to start over, so that's year 1, and then in year 2 it's the same thing. I'm going to have to add another 5% on again then, aren't I? So what is 5% of 1,260? So again, I'm going to say that's 100% of what I've started off in year 2. 10% would be a tenth of that, that's 126. And 5% would be half of that. Half of 126 is 63, isn't it? So again, I'm going to add on my 100% and my 5%, and that's going to give me 105%. And 1,260 plus 63, that's going to be 1,323, then adding those two numbers together. So it was £1,200, it's now 1,323. So interest earned is going to be the 1,323 I now have minus the 1,200 that I used to have. So that is 3, 2, 1, and 123. £123 in interest. Okay, I've shown it. Right, well, this is a very wordy question for 1 mark. 25. A machine makes bolts that should be 30 millimeters long, correct to 1 decimal place. Jane checks the accuracy of the machine by taking a random sample of 10 of the bolts. Here are the lengths in millimeters, correct to 1 decimal place, of the bolts in Jane's sample. Jane says 6 of the 10 bolts in this sample are the correct length. That's 60%. Therefore, 1,200 of the 2,000 bolts will be the correct length because that is 60%. Give a reason why Jane's claim may be unreliable. Well, this is only a 1 mark question, so I'm just going to go for an easy one. I'm just going to say her sample is very small. So look, her sample of 10 bolts out of 1,200, that's not many, is it? 10. And so, I mean, you can only get that accurately. And she's come up with 60%, and you can only get the percentage to the nearest 10% then, can't you? Because you only got 10. I don't think that's going to be particularly accurate. So I'm going to say the sample size of 10 bolts is very small. That's it. That's all I'm going to say. The sample size is very small. So a lot of words there, but quite a simple, straightforward answer. Question 26. In a survey, 50 people were asked whether they have a car or a bicycle. The Venn diagram shows some of the results. The ratio of people that only have a car to those that only have a bicycle is 2 to 1. One of the 50 people is chosen at random. Find the probability that they have a bicycle. You must show your work in. Okay, well, first off, we need to complete the Venn diagram, don't we, before we can actually answer the probability question down below. And to do that, we're going to use this ratio here. Only having a car to only having a bicycle in the ratio of 2 to 1. Okay, so we need that to work out the rest of the Venn diagram. Now we know there are 50 people altogether, and we've already got 2 values in the Venn diagram. We've got that 1 and the 10. Okay, so how many is left then? We need to then divide out between these only having a bicycle and only having a car. Well, it's going to be the 50 we had to start with minus the 2 numbers that were appearing already. So I've got like that 10 and that 1 in there, haven't I? So 10 plus 1, what's that then? Adding those in and taking it away from the total. So that leaves me with 10 plus 1 is 11, and 11 taken away from 50 is 39. So I've got 39 to allocate between these only having a car and only having a bicycle. So I need to do basically I need to divide by a ratio, don't I? I want to divide 39 in a ratio of 2 to 1. So 2 plus 1 parts is 3 parts. So then dividing 39, 39 divided by 3 is 13. So then taking my ratio of 2 to 1, 2 to 1, and scaling up by a factor of 13, I'm going to get 26 to 13. So that means 26 only have a car and 13 only have a bicycle. Okay, so now I can complete the Venn diagram. So that must be 26 over here and 13 here. Okay, so you might want to double check that all adds up to 50, but I think it does. Then it says find the probability that they have a bicycle. So anyway, that was the yellow one, that was the green one. So find the probability that they have a bicycle. You must show your work in. So the probability of a bicycle is the total number of people altogether. There were 50 if you remember. And then how many people have bicycles? Well, it's going to be the 13 we just found plus the 10 in the middle, isn't it? So it's going to be 10 plus 13 for that one. So the 10 plus the 13 is going to be how many there are altogether. 10 plus 13 is 23, so that's 23 over 50 is our final answer. Question 27. In this question, all lengths are in centimetres. So I've got a rectangle, it's got algebraic sides, x minus 2 and x plus 7. The area of the rectangle is 70. Show that x squared plus 5x minus 84 is equal to 0. Okay, well, if I want to find the area of a rectangle, I know it's length times width, don't I? Now, the length of this one is x plus 7, and the width is x minus 2. So if I multiply that together, I'm going to use a grid. There's lots of different ways you can do this. I like the grid method because it has a space for every answer that you're going to get, and people often miss bits out of this otherwise. So x times x is x squared, x times 7 is 7x, x times minus 2 is minus 2x, minus 2 times 7 is minus 14. So I've got a term in x squared. I've got two terms in x that I kind of need to collect together. So what's minus 2x and 7x? Collecting those together, 7x take away 2x is 5x, and then I've got minus 14 on the end, so minus 14. Okay, so that's from multiplying out the brackets. Now, I was told in the question that the area of the rectangle is 70, so we found an expression for the area, and we've been given the area, so that means we can equate those two things together. So I've got x squared plus 5x minus 14 is equal to 70. Now, to make it into the form that they want, I want it equal to 0, so I need to rearrange this. I need to move the 70 to the other side. So I need to subtract 70 from both sides. Subtract 70, subtract 70. That's going to give me x squared plus 5x minus 84 is equal to 0. Okay, so I've shown it, haven't I? So that's been shown. Solve by factorising x squared plus 5x minus 84 is equal to 0. Well, if I want to factorise it, I need to put it into two brackets. I've got an x squared at the beginning, so that means I'm going to have an x and an x in my brackets. Okay, I've got signs, one of which is positive and one of which was negative. Now, if it ends in a negative number, it must mean that one of my signs is positive and one of my signs is negative in the brackets. And then I've got a number 84 on the end. So my two numbers in the brackets must be a factor pair of 84. So what are the factor pairs of 84? I've got like 1 and 84. Does it half? Yep, 2 and 42. Does it divide by 3? Yep. What's 3's into 84? Well, 3's into 60 go 20 times, and then 3's into 24 go 8 times, so that's 28 then. 4's into 84, yes, it goes 4 and 21. 5, no. 6 is into 84, yep, that works. It's 6 and loads of factors here, isn't it? 6 and 14. 7's into 84. Yeah, 7's a factor as well. There's loads of factors. 7's and 12. 7 times 12. What else is there? 8? No, 8 doesn't go in. 9? No, no 9. 10? No. 11? No. That's all of them. Finally, oh, gosh, that was a lot. Now, got tons of factors here, but I'm looking for a factor pair that adds up to 5. Positive 5. So remember, one of these is going to be positive and one's going to be negative. So it's actually the difference between the two factors that are going to deliver me that 5 in the middle. So scanning down my list, taking one factor away from the other, I can see that these two, 7 and 12, that's the one I'm interested in, because 12 take away 7 is 5. So that means I must have a plus 12 here and a minus 7 there. So when I multiply out the brackets, it's going to give me that 5 that I need at the top there. Okay, so plus 12 minus 7. Okay, right, so we're good. Oh, no, not quite done yet, because that is equal to 0. Now, if you've got two things that multiply together that equal 0, then that must mean that one of the things was 0, or the other one of the things was 0. And if x plus 12 is 0, that means x is minus 12. If x minus 7 is 0, that means x is 7. So find the length of the longest side of the rectangle. Okay, well, we know what x is now. Well, we've got two values of x. Now, the value of x in the rectangle can't be minus 12 because that would give you a side that was negative. That doesn't make sense. So we're going to be using x is equal to 7 and not x is equal to minus 12. It has to be that solution. Okay, so what is the longest side? The longest side is equal to x plus 7. That's then going to be 7 plus 7 is going to be 14 then, isn't it? So that's my final answer. It's going to be 14. Tricky last question to finish on there. 8 marks as well, quite a lot there. How did you get on?
Mr. T, he's the best. Helps you ace every test. Maths worries now.